All right. Okay, so I'm just gonna talk about Friday real quick. Binomial, and then we're gonna do geometric, which is similar. Not too big. We're gonna do these notes, which aren't that much. And then there's an assignment on Schoology. And then tomorrow was supposed to be a second period half day. We were gonna do like a little mini chapter 6 test. Now you need to do it at home by Friday.
I'm literally not gonna remember.
So like there's no class time for
I
it.
literally have
On Friday we're just gonna start what we would have. So there's a homework assignment due, and then there's like a little at-home test.
Can we still have silver?
By Friday or by
So tomorrow's like the first
What
period.
the heck? Why blue all the time?
I don't know.
It's always blue.
Yeah. All right. So let's go over this, and then we'll have time to work on the assignment so that we can go through it. Let me just talk about Friday. So we talked about binomial, and there's an acronym, BINS, even though the S at the bottom doesn't really make as much sense. But the B was binary, like two options, like a yes or a no. Like is it what you're looking for, this outcome, or not? So is it like basically, is it your outcome or not? Are all the events independent? Do you remember what we used to say independent?
The 10%.
Yeah, what's 10%? That's right.
10% of the total population.
Yeah, so our sample size less than 10% of the population that you're looking for. So it needs to be small enough to where your samples are going to be diverse, is what that means. What do you know? What about the N? What was that?
That is the amount a sample has in a fixed amount of trials.
Wow, okay, that was complicated.
I don't know
Fixed
how-
amount of trials, like N equals whatever, a number. Like there was a fixed amount. This is where we're going to change today instead of having a fixed amount. And then S had nothing to do with S, except you could say like same probability throughout. So like every single outcome, every single probability had the same chance. So like a 5% defective item is 5% every item, or whatever. Okay, so that was binomial. Geometric, so at the page here, it says geometric is suppose an experiment has all the conditions of a binomial except that the number of trials is not fixed. So not a fixed number of trials. So geometric, no fixed number of trials, like samples. Like it's not a I'm not going to do a sample of 10 people and ask how many of those 10 whatever built a snowman. Okay, instead of the trials, it will be until the first success is observed. So like my snowman example, how many people is it going to take me to sample until one of them built a snowman? So like what's the probability it's going to take me? Alright, so it is like flipping a coin. Like how many times is it going to take me to flip this coin until I get heads? Not how many heads did I get out of 10 flips. Okay, that's our difference. So the probability is still the same, they're independent, it's binary, but there's not a fixed number. It's like until the first success. So some examples on your page there. That box is like a messed up version of the formula sheet. So if you just grab the formula sheet, we'll go through it. So some examples. What's the probability of the first car arriving at the service station that needs brake work? What's the probability of flipping a coin until the first tail is observed? Probability of the first plane arriving at an airport needs repair, and so on. So like seeing is it binary or binomial or geometric is like fixed or not is the difference between them. So like the homework, the worksheet you'll do later has a mixture all combined. Okay, so let's look at number 1. And we're gonna do D first. Actually, we're gonna go down to D. So Number one, the drilling records for an oil company suggest that the probability the company will hit oil in a productive quantity at offshore location is 20%. So they're guessing its probability is 20% productive oil. Suppose the companies plan to drill a series of wells. Okay, I'm gonna go to D first, just because it talks about mean. Find the mean and the standard deviation. So find the average, the mean number of wells that must be drilled before the company gets its first productive well. So what is the mean number of wells? So X is like a productive well, offshore well. So what's the average number it's going to take me until I get a first success in this case? So on the formula sheet here, right under binomial, it says geometric, and it says the mean is 1 divided by p. So in this case, that'd be 1 divided by 20%, which I believe if you do that, is it 5? 1 divided by 20% is 5. So let's think about what that means. That means, on average, like when I'm going to drill a well, it's going to take me 5 offshore wells, like doing it until we get a productive one on this case. That's what in this certain scenario. So it's going to take an average about 5, and then standard deviation. Again, just looking at the formula sheet, it says 1 square root 1 minus p over p. So the square root of 1 minus 20% would be the square root of 0.8, 80% divided by 0.2, 1%. Which becomes, is it like 4.47?
Yeah, 1 minus 20 over.
So the bottom piece not squared?
No, is y'all's formula, or?
On this thing,
It's right on the top.
So on this sheet, on y'all's note sheet, it says this. That would be because the whole thing's being square rooted. This one is, the p is fine. It'll give you the same answer.
Yeah, it did.
It's because this one has the whole thing square rooted. Yeah. Okay, so let's just interpret what this means. We're saying on average, it will take 5 offshore wells before we get the first successive one. But we have a standard deviation of 4.47 wells. So
So it might take
The-
1 drill, it might take 9 drills.
yeah, 1 to 9 is where a lot of our numbers lie. A lot of them are in that 1 to 9 range. So anywhere within there. Okay, let's find some probabilities. What is the probability that the 4th well drilled will be the first productive well? So that it takes until x equaling 4. So what's the probability that the event x, a successive well, the first successive well, will equal the 4th one that we do it? So that means the first 3 are bad, times the 4th one being good. So yeah, so let me, I guess I'll pull up the thing on here, the Inspire. So what we're gonna do is, since we're looking for the first productive well, we're not looking for there's no fixed number of trials. It's the first successive one is the 4th one. So because of that, it's a geometric distribution. So there's no fixed number. It's not like 4 out of 10 or whatever. And then it is equal to 4. It's not greater than or less than. So it's equal to, so that means it would be a PDF, geometric PDF. gonna go to menu on the calculator. Go to, oh, that's calculator. Why won't it do it? It doesn't want me to do anything. There we go. Okay. Menu, statistics, distributions, and then, ooh no.
It's H.
The board is off. H. Let me try this. The distributions, scroll down, all the way down towards the bottom. And we finally made it. H. Geometric PDF. Probability of success, 0.2. X value is 4. So it's probability that our fourth one is the productive one. And 0.1024.
Yep.
So about a 10% chance that that first one. So let me see something. Okay. So with geometric, I'll just write what I did. So that would be x equals 4, and it's 0.1024. So geometric distributions are actually not too bad to do by hand. So if you think about this one, there's not all these, on binomial there were like all these different ways you could do that one distribution. On this one, to have the fourth one be successful, there's only one way. It would be that the first one is not productive, which is an 80% chance. Being productive is 20%. So the first one is not working is 80%, times the second one not working, times the third one not working, and then the fourth one finally working is a 20% chance. So times 20%. And you actually get that same thing. So you don't have to do it by hand, but geometric is actually a little easier. But since we do binomial on the calculator, you're more than welcome to do, like, just to keep doing it on this. Just to show you the first three don't work, times the fourth one works. So, alright, B, what is the probability that the seventh one is the first productive one? So that exactly the seventh one is the first productive. So again, another geometric PDF at 20% chance every trial. X equals 7. And just, if you are wondering by hand, so it would be like the first 6. 1, 2, 3, 4, 5, 6, and then the seventh one is the productive. That's going to give it, both those give us the same answer, which is like 5%, 0.0524. What's that?
So when we're writing under the genomial PDF thing, can we just put the parentheses 0.2, comma 7, or do we have to write out 15 and X?
Yeah, write PX to really show, like, anytime you're using calculator, make sure you write that you actually know what's going on. Yeah. They want to see what you did and that you knew what it meant. Alright, and then we can do C. Is it likely that X would be as large as 15, i.e. OU would have to drill 15 wells before finding a well that was productive? So basically is it likely that you would get all the way to 15? So that's just asking, you actually could do two different things. Like, could be, yeah, let's do it this way. Is it likely that it could be as large as 15? That means 15 or bigger. So that would be like asking the probability that it takes greater than or equal to 15 of these. So before I get the first productive one, so we're still doing geometric, but then it is a CDF because it's all the ones bigger than. Let's see. So stat, distribution, geometric CDF, so you've got P of 0.2, and then it asks you for a lower and an upper. So we're looking for 15, and then for the upper, just put a big enough number that's basically infinity, which in this case is 100's even big enough. I mean, if you needed to, you could go 1,000, 1,000,000, whatever, but I think 100 is plenty big in this case. 0.2, 15, 100. Let's see, and there is, that equals 0.04398. So like a 4% chance is it likely that you'd have. So all the numbers 15 and greater than, 15 to 100, combined together to be a probability of 4%. So is it likely? I would say it's not very likely. Like that's a super small chance. So we're actually going to get into on Friday, and like for the rest of the semester, we're going to get into like how likely it's, and 5% is kind of your cutoff. If you have a probability of less than 5%, then it's like pretty far happening. But geometric CDF in this case, that's a pretty small chance. But, so
Is
we're,
that just a percent or as a, like, number? Or like is the 0 point whatever?
what?
Like, do we need to write it, like, when it's saying how likely, are we writing it as a percent or like how we have been writing it?
You can write it either way, decimal or percentage. Yeah. They like decimal. They give their answers in decimal on keys a lot, but like,
It doesn't really matter.
yeah, I like to say these in percentages so that you understand the connection every day. Like you're realizing this is just the number 5%, 4%, whatever. Okay, let's do a couple on the back. Try it out. So, an insurance company expects a salesperson to achieve minimum monthly sales of $50,000. Suppose that the probability a salesperson sells $50,000 of insurance any given month is 84%. So they're telling us to assume, to suppose that in general there's an 84% chance of selling 50,000. If the sales in any one month are independent from another, what is the probability that exactly 3 months will elapse before the salesperson reaches the acceptable minimum monthly goal? So what's the probability? Yeah, probability that exactly 3 months will elapse before they reach. Trying to think about this. So, probability that it's exactly 3. So, probability x equals 3. So, like our instance, I probably should have done this on the other page. So, like if you're kind of going through the binomial,
Are we still supposed to use that on this?
well, we can kind of point out like independent. I was just gonna reference it, but it's not the same. Like, so the n is not fixed, so you could kind of say like not fixed equals geometric. So like there's not a fixed number of trials. We're saying what's the probability it takes 3 before they finally reach the minimum goal. Where probability is, what's it, 84%. And we're saying, basically, did they get $50,000 or not? That's supposed to be a K. The best K I've ever seen.
So would binomial be like over the course of a year? What's the
So-
probability of being 3 months, so it has to be like,
Yeah, binomial in this case would be like, yeah, what's the probability that in the next 3 months that only one of them had it, like 1 out of 3. So binomial would be any one of the 3. This is saying what's the probability it takes the third one until we get that first.
okay.
Yeah. But if it gives you like, yeah, blank out of the total, like what's the probability of that? Alright, I was trying to think about this. Before I think about it. Yeah. Okay, that's right. So, what we have, geometric distribution. So technically, like really by hand, it's not too crazy. So let me think about this. Like there's 3 months. Here's the 3 months. And I'm going to multiply the odds. So this is the odds of any salesman getting to that $50,000 mark. So them not getting it in the first month is 16% chance. And then there's a 16% chance the second month he doesn't get it. And then what's the probability on the third month he does get it? Like that's doing it by hand. So that's first and second month. This is the third month. And that would give you the same answer as doing a geometric PDF probability